let's see the other side. Okay, so we should be seeing results here shortly. I might reload once. Okay, we don't have connection yet. Yes. Okay, we should be back now. Okay, everybody gave their vote. Looks good. So it seems like people definitely say Landgraph is the mostly used one. And to give you the reveal of this, you're right. Landgraph definitely has the highest monthly downloads with around about 4 million downloads. Downloads next in line is Crew AI with also roughly 1 million downloads. And then we have AutoGen and at the lower end, the Agent SDK, but also the Agent SDK, as you guys might know, just came out a couple of weeks ago. So it just doesn't have that large of a distribution yet. All right, then let's get started with the agentic design patterns. We're gonna actually implement all of these 4 design patterns from scratch in the notebook. That means you yourself are going to implement 4 agents yourself today, together with me. We are going to start with the reflection pattern. So this is the most basic pattern. And the idea, oh yeah.
Could you give the link for the notebook again?
Yeah, the GitHub, right?
Yes.
Yeah, let me pull that up for you again. So it's on my GitHub, Leonie Freisinger. And then you take the ADPAO repository. Got it?
Yes, thank you.
Perfect. All right, reflection pattern. The idea of the reflection pattern is that instead of only one LLM generating output, we have 2 LLMs. One is generating output, and then there is another LLM, the reflection LLM, that gives feedback on the prior output or a critique, and then funnels it back to the generator LLM. And this can go in a loop as long as you basically want to, either setting a condition where we say the output is good enough, or just defining a maximum number of iterations. So what do we need for this reflection pattern or the reflection LLM? It's 2 LLMs, and for each of them, a chat history. So we have the generation chat history, and we have down there the reflection chat history. In general, just a quick note, I'm going to use the OpenAI models for all of the notebooks, so we just have one client from OpenAI implemented here. You can, though, if you play around with it yourself, just import any of the other models you wish for and just exchange that. Okay, so what do? We basically give the generation LLM a prompt, which is this one here, and we say, hey, you are a generator, so please generate something, and you also will get critique or feedback. So take that feedback and then improve your output. This is what we're doing here, and then we're appending a user question also to the generation chat history, which in this case is, please implement a version of the bubble sort algorithm. That's just a random example, and we do that, and then here we let the first output run. And as we can see in a second, it generates a first output. I already printed it here. And we see, okay, it's a basic version of the bubble sort algorithm. We don't have to go over it in detail. Now we take this output and go over to the reflection step. Meaning we take it down here and add it to the reflection chat history. Previously, we though tell the reflection LLM also what it's supposed to do in its system prompt. And we say, hey, in this case, you're Andrei Karparfi, and you are supposed to generate a critique or a feedback for the output you see. So that's what we do. I'm not going to execute off all of the cells because sometimes it takes a lot to run, but if you'll execute it yourself, you will see. And as we pass it to the chat history, we now let it create the critique. And as we see here, when printing the critique, it says, okay, here I have some recommendations for you. Maybe you should add a doc string, for example, to your code. And this critique we're going to take in a next step and add it again to the generation chat history and let the generation LLM run down here again. So if we run it and let it display its output, we see, okay, now the basic version of the bubble sort algorithm has a doc string based on the critique of the previous LLM. And basically, that is already it. So you can do that multiple times of like appending each LLM's output and let it run in a loop until you would say it's good. And the nice thing is, with those steps, you already have built a reflection agent. I built that one for you, so later if you have a look at the code, you can just go in here into the source folder. We have like the different agent classes implemented here. For example, I quickly open it for you. We have the reflection agent. It's basically the same code we did, just rearranged in a class. And you can easily now import the reflection agent, instantiate it, and then have it run down here for the final result. Okay, we would need to run the whole thing again. I'm not gonna, well, I can run it real quick. Okay, no, I would need to run a few more cells, but try it yourself. And then we put a number of 3 maximum steps here. So it will go 3 times in a reflection loop and then print the output. Now a quick remark on that. As you've seen, some of the cells take quite long to run, so having that reflection step in is always a trade-off on compute, but gives you a better output in the end. Also, another remark on the reflection step. Let me jump here. So there's this basic reflection, as we've seen, where there's 2 LLMs, a generator LLM and a reflection LLM. But nowadays, most of the frameworks, most of the agent frameworks have that self-reflection implemented. That means they don't have 2 separate LLMs, they have it both in one LLM. So it generates the output and the critique in one go, and it just does the loop with itself, so to say. And there has been a new concept as well, which is called reflection. And there the idea is that we have exactly that self-reflection step, but only once, and then pass that output to another self-reflection LLM that though has a memory buffer. That means it can keep track of the output it generates, and therefore has a better baseline to iterate upon and to improve. So it's actually that this reflection leads to better results overall. All right, before we go on to the next pattern, any questions? Yeah.
So for self-reflection, we're using the same there's this single LLM. There are these biases that LLMs have, that they prefer their own output. So if we compare this setup with where you have the reflection LLM is different from the generating LLM, is there a comparison of which outputs are better?
I bet there is somewhere a comparison, not that I have looked it up though, but it seems very reasonable for me. And also if I would need to get something, I bet the 2 LLMs lead to a better result. However, they also take more compute and more time. So the self-reflection is just a faster way to go in that case.
And it's more compute because you need to send more queries, or is it because it's just, or there's some other?
More compute time, I would say, because you generate an output, you need to pass it on to another LLM, then it needs to pass its output again back. Yeah.
Okay. Thank you.
Cool.
Can you repeat what is the memory buffer used for?
So the memory buffer it stores basically its own output in the memory buffer, and each time its output changes slightly because it, for example, adds further information to it, further references, for example, that just make the output better. And it stores basically all the steps so it can keep track of, did I get better? In what direction did I get better? Yeah, one more?
Sorry, same to the question. So the memory buffer is to store the context, actually the text message we have the conversation with that or?
So primarily the memory buffer is there to store its own output, but also there's different experimentation with that reflection around. So sometimes they also just try to gather more context and then store it in the memory buffer. That's right.
And is that a database?
It's a database, yeah. It could be any kind of database. you can like implement it as a database. Sometimes you can also just append it to the context. Yeah. Great. All right. Then let's jump on to the next one, which is tool use. So tool use, I'm sure you all have heard of it, is quite common in the meanwhile, I would say, or right now. The basic idea of tool use is that LLMs themselves, they have limited knowledge. So if they don't have any way to the outside world, they just know what they know and they can reason based on that. However, with tool use, we enable them to have access to the outside world. And tool use really could be anything. It could be using a search tool to Wikipedia. It could be using a tool to access a database, or also just a simple calculator. And it really all comes down to a simple function call. So a tool is a function call. And what we are going to do is implement that function call and make an LLM basically a tool calling model. And we start with a very simple function. So here's the get current weather function. You can pass a location and a unit, so for example, Barcelona and Celsius into it, and it returns you a temperature. We also just executed that here, so you can see the function itself works. Now, how can I get this function to be used as a tool by an LLM? Therefore, we need to pass all the relevant information about that function to the context of the LLM. And this we do through a system prompt. So first of all, we tell the LLM, hey, you're a function calling AI model. And then we give it information about the name of the function, the description, and also the input parameters. And important is that we give it that information inside those tool tags, because this way the LLM will recognize that this is a tool. And every time it uses that tool, it will display it in a tool call, or within those tool call tags. And that's basically already the whole magic. So we're going to go ahead and do that. We have our basic imports, and there we define this tool system prompt, which is essentially what we just talked about. So we tell it you're a function calling AI model, and we pass it the tool in here, and also tell it that it should return it if it uses it within the tool calling tags. So now we're going to test that function. Down here, we add the tool system prompt to the chat history, and we add a user message that says, what's the current temperature in Barcelona in Celsius? And we let it create the output, and what we see down here, okay, it outputs that exact tool call. It's already good, but not exactly what we want yet, because it's only the tool call, and we want to know the result. And what is still left here, we have to pass this output, and like, so to say, extract its input parameters, then pass it on to the function, and call the function itself. So this is what we do with this parsing function here, and if we apply that parse to a call string function to the output, we see, okay, it returns the input argument, and with these input arguments, we can call the get current weather function, and eventually it will then return us the right result. So these are the steps to have an LLM basically become a tool calling LLM. And then, in the end, this function call output we again pass as an observation to the final step of the LLM itself, and it will return you the final answer to the question. Now, this is quite nice, but it's also a lot of effort to like go down this path all the time. So what I want to show you is the tool decorator. The tool decorator basically can wrap any function, any random function, such as the get current weather function, and make it available as a tool to an agent. So just to showcase you another example, we have a new random function, which is called fetch top hacker news stories. And what it basically does, we can demonstrate once down here, it just fetches the top 5 news, I guess, from Hacker News. And what we do here, we now apply this tool wrapper and make it a tool. So if we now look at the Hacker News tool instead of the function, we can see it has these attributes we were talking earlier about. So it has a name, and it also has a tool signature, which has this description and also the input parameters. And what we can do now, so I went ahead again and implemented all the prior code in another tool agent class. You can find that one also in the source folder. We're going to instantiate that agent and just pass it that tool we just defined and see what it does. So if we call it to generate the output, it really uses that function now as a tool, and as we see here, it does the function call, and it also returns the results we had returned earlier by the function itself. Yeah, and that's already it. That's all you guys got to know about tool call. Do you have any questions? Yeah.
So for the specific tools you're using, the information, at least in the examples, all is, say, information that is like more current, like the weather. So do you have to force it to go to the internet to find this information at all?
That's a very good question. So in this case, the get current weather function, if we have a look at its implementation, is just a dummy function. So to say, it has a very simple logic that if the location is Barcelona, it returns you 32, otherwise it returns you 58. But in general, we're going to have a look at this later as well. There is, in certain agent frameworks, either already web search tools implemented. So for example, in the OpenAI Agent SDK, you can just import a class, it's called web search tools, and it does the web search for you. Or with other agent frameworks, you can use third-party frameworks such as Tavily, which also allows you to get access to the web. Yeah. Yeah.
Oh, sorry. This is very interesting. I think there's open source like web browser named like open browser somewhere.
Yeah.
Have like 80% of correctness. I play with that. It's quite good.
Mm-hmm.
Also like searching weather, you can also use free APIs.
Yeah.
I built something like you just call it 5 minutes to do the same thing.
Nice.
Right, and because of the ChatGPT can do all work manually.
Yeah.
Is there any? Yeah, that's a very interesting thing. Yeah, actually.
Yeah. Did you have like any preference within the different tools that you tried?
No, but I find it's very difficult if you try to build all the tools by yourself. It's very time consuming.
That's true.
Yeah, it's end up to why I'm doing these things. Except hobby.
Mm-hmm.
Yeah.
Okay, got you.
Yeah, but it's very interesting, I think.
Nice. You had a question as well.
I just mentioned the Monica Lab, Professor Monica Lab has a project called Genie. So the spirit of the project was you have programming language and you have this nature language. And they try to do semantic parsing. So for example, you have a Yelp kind of interface. You want to reserve a restaurant, right? You have location, you have cuisine you like, time, and the cost constraint. And so you know the signature of an API you need to call. But then you know the signature, but when you want to interact with the user, you can say, do you want to reserve a restaurant? User type in 3 constraints. But then you know the API needs 4. So now the GPT itself can be smart enough to say, hey, can you tell me what will be your cost constraint? But before you just cannot do it, right? Before you know there are 4 constraints, but it's mistake, you mistake. But with this kind of integration, the dialogue will be generated for you automatically because there's one missing argument. So this is really nice.
Yeah, I agree. Totally agree.
Yes.
Yeah.
Is MCP a form of this tool used to like multiple tools to build for LLMs to access?
So MCP itself is basically a standard for an interface that lets you interact with different entities, so to say. So I wouldn't say that MCP itself is like tool use, but it gives you a standardized interface standardized interface on how to do it.
And then people build the tools and they use the MCP as the architecture.
So MCP they basically use as the architecture or as a, maybe you could even say layer. I like to say interface to have that in a streamlined way and to have like a client server architecture. Yeah. All right, then let's jump on to the next one, which is planning. Planning is a pattern that is also quite core to many of the agent frameworks, especially that technique of REACT, so reasoning in action. And the basic idea of planning is that we help an LLM to break down a larger goal into smaller steps without losing track of the end goal. And therefore, the LLM goes through those 3 steps, which is first, it reasons and makes a plan of what to do. Then next, it takes the first action of that plan. And then lastly, it looks at the observation and where it landed, so to say, to then resume the plan and keep on going with the next step. And yeah, just already a view I had. So for example, LangGraph, the agent framework LangGraph, they have a built-in method of an agent called create React agent. So it inherits exactly that one here. All right, so let's implement that. We're gonna go through like multiple React loops to get the whole workflow down. So we're gonna go through the thought, action, observation step. To do so, we give a quite holistic React system prompt, and it first tells the model that it should come up with a plan. Second, that it should do an action and can use the available tools for it. So this is quite similar to the tool use we talked about a few seconds ago. And then we tell it to generate the output using the tool, and then taking the observation. So the output of the tool use is basically the observation, and have the model call again to then output the final response. And we're gonna look at this in multiple use, and we're gonna use a few tool examples. It's basically just mathematical operations, so sum of two elements, multiply two elements, and compute the log. And then we go ahead and get started, and okay, we still have to add the tool signature together with the system prompt to the overall prompt, so we have like the tools ingested here. And then we go ahead and get started, and we want it to calculate the sum of 1, 2, 3, 4, and 5, 6, 7, 8, then multiply the result by 5, and eventually take the logarithm of this result. And the first step is basically having it planned. So it says I need to first calculate the sum of 1, 2, 3, 4, and 5, 6, 7, and it knows, it already selects which tool it wants to use for that. Then this one is the output. What we're gonna do with that one in the second step is extract the arguments and then also create the answer. So it extracts the argument, then it's being loaded, and then it's being put into the tool call. And we see, okay, we gotta see here, okay, I didn't print it, but it knows it needs to call the function sum of two elements with those two input arguments. So it essentially does the right thing. And then it takes this final output, the observation, and adds it to the chat history. So this allows it to then just generate the output again and have the first answer to the first step. And then it keeps on going with the next step, so the next plan step. It says now I need to multiply the sum 6912 by 5. Then it does the whole thing again. So it knows already which tool to use. It then calls the tool, and it adds it as an observation to the chat history, and then lets it create the final output again. And then the last step, it knows it needs to compute a logarithm now, and it selects the tool, does the same thing again, adds it as an observation to the chat history, and now eventually it's able to produce the final result, which is the logarithm of the result is approximately 10.45. And this was like, I guess in total 3 loops to complete this task of doing this mathematical calculation. Also in this case, we have the React agent as a class implemented in the source file, so you can just call it, pass it its tool, and pass the user prompt, and then it will run autonomously by itself. I can actually, let's see if we have all of them imported. I can just let it run in the background, and you can have a look at it just like it going through the thing. In the meanwhile, do you guys have questions on tool, on planning? Yeah.
So it generates thoughts one by one, like it generates thoughts after computing each result, like each substep, or it generates first just the entire plan and then executes them one by one?
That's a good question. That depends on how you prompt it. You can either prompt it to like only output the first step, but in general it always makes a plan first, so it needs to know the end goal. Yeah. Yeah.
So how do you compare this with the chain of thought? Do you solve
Mhm.
one by one.
Mm-hmm. So you mean how it compares with it in terms of steps? Because with the chain of thoughts, it's like mostly sequential, and it doesn't really do that check back loop of, okay, now I have achieved step 1 and I need to do check back on what is my higher level goal, right? That's missing with the chain of thought.
Yeah, there was an interesting paper just
Mhm.
was not published, but was a professor gave a talk saying the problem of chain of thought is you get context convoluted as you progress to the next step and the third step.
Yeah.
So he came up with this paper titled something like pencil or eraser, saying after the first step, you erase all your context, only save the final result.
Mm-hmm.
When you progress to the next, right, then you don't have this all the polluted context to mess up with your second step and moving forward. Of course, the best way is you have 3 agents, you pass the result to the next agent with a clean slate.
Yeah.
But the problem is, suppose you want to reuse certain context in the beginning, then you lost it.
Because it's erased, yeah.
Right, so it's kind of challenging.
That's why I think it's like a good in between if you at least do not erase context of the final goal, because then you can have the final goal and maybe the context of the -1 step -1, and erase the rest, but at least you keep the final goal in the context. Yeah. Yeah.
I think it's very interesting. Seeing I thought like as the professor says, like you sometimes you want to remember your best step, and when you fail, you want to roll back to the best step and then go forward. And sometimes I think the most issue is like you lose your path and you cannot go back. They give you another path, and another path didn't work at all. And is that this can solve the problem, right? Basically, I think.
I'm not sure whether this can solve the problem with the rollback. There you would need to have like some kind of separation of the memory. One part of the memory you can pass as a context, and the other part of the memory you just keep basically for the rollback scenario, and then decide at a later point in time to maybe again pass it. This way you could like avoid the pollution, I guess, but also have your fallback scenario still set up.
Yeah, if you can have like another as observer, which is bad or not bad, and then if it's good, then you can remember, store the best step for the user.
Yeah.
Yeah.
That works, yeah. All right, further questions? Then let's move on to the last pattern. It's the multi-agent pattern. So this is basically the first pattern where we really have multiple agents collaborating with each other. For sure, also in the reflection step, we had like different LLMs involved, but it always was in a quite sequential manner. Now for the multi-agent pattern, we follow the approach of Crew AI. This is one of the agent frameworks. We're gonna dig a bit deeper in a second. And the Crew AI follows the idea that we have multiple agents, and each one of these agents has a certain role defined. So that also brings along that they get all their own goal or all their own task to achieve. And then we have this concept of the crew, which means that all these agents together are there to achieve the higher level goal. And the way we do this, we can just go through our first example agent. So we have this agent class here, and we give an agent a name, for example, the poet agent. We give it a backstory, a task description, and also expected output, so the goal that it's supposed to achieve. And if we run that agent down here and have it have a look at its output, we see, okay, it just gave us a poem. Now we can also give these agent tools. So what we're gonna do here is we define a tool, as we learned earlier. In this case, it's the function write string to text, because this agent here is outputting a string. We want another agent that is able to write that string into a text file. So we're gonna instantiate another agent here. It's the writer agent, and it also has a backstory, a task description, and an expected output, and we pass it that tool we just defined above. If we look at that example, we can also just run it real quick. We can see, okay, it writes a text file, and it also just did that. Let me show you here. It said, okay, I write this text file, and in this case, it only wrote in there, this is a tool agent. Now the next thing that is relevant for multi-agent pattern is defining a way how they collaborate together, right? So this we do by defining dependencies. And we have our two agents again. This time it's the poet agent and it's a poem translator agent. And the way we can define dependencies, at least for the concept of crew AI, is with that right shift operator. So we can say agent 1 right shift agent 2, and that means agent 2 depends on agent 1. In this way, you can like do arbitrary combinations. You can have multiple agents depending on each other. You don't gotta be careful that you don't confuse it too much. If we look at the different agents' dependency, we see, okay, agent 1 has no dependencies, but it depends on it has no dependencies, but it has a dependent, which is the agent 2. And agent 2 has a dependency to the poet agent, but has no further dependence. So this is how the system works there. And if we run it, then let me quickly see, let's do that. If we run it, we see that the context or the output that is created from agent 1 is added to the context of agent 2. So this is the context of agent 2, and as we see, it matches the output. Because if you define a dependency, it means that the output of the prior agent is the input to the new agent. All right, and then let's do the final walk, which is defining a whole crew. So in this case, we have 3 agents, the poet agent, the poem translator agent, and the writer agent. The writer agent is the only one that uses a tool. And we do a line of 3 dependencies. So agent 2 depends on 1, agent 3 depends on 2. And we can also just have them run again. I think it takes a bit of time. So first agent runs. It creates the poem. Then we have the translator agent. We see, okay, it was English prior to that. Now it seems to be some kind of, I don't know, Latin maybe. And then we have it write a text file, which is this one here with the poem. And that's basically the simplest version, I would say, of a multi-agent collaboration pattern. All right, before we move over to the frameworks, do you guys have questions?
I think this is, oh, sorry. There's student.
You can go first.
Okay, so this is great. So one question is, you have to kind of crafting the crew manually, or you can just give the spec, then the crew will be automatically formed.
Yeah, so in this case, unfortunately, you have to do quite a rigid definition, I would say, of the dependencies between the agents. So you really have to use those right shift operators. And that's also, I would say, a drawback of Crew AI, the agent framework. While with other frameworks, for example, LangGraph, it bases on a graph. And with that graph, and just, I would say, defining more loose connections or potential connections between different agents, you're able to basically implement different architectures of multi-agent collaboration with the same basic framework, and you can keep it more flexible, more dynamic. Yeah. Because this would be the goal, right? That it assembles its architecture on itself, by itself. Yeah. All right, your question.
It's a little bit related, but can an agent depend or have dependencies on more than one agent, or is it always linear one-to-one?
Yeah, so in Crew AI, it can also split up. So you can even see it like as a router. There is like one agent, and agent 2 depends on the output of agent 1, but also agent 3 depends on the output of agent 1. And then maybe agent 4 then again depends on 2 outputs from 2 different agents. Then it's like, I guess, this shape of the flow. So that's definitely possible. Yeah.
Actually, it could be an interesting project. Let's say you have downstream state, right, or task. You depend on 3 upstream tasks, like supply chain situation. If you have electricity, power, and you have the chips, whatever, together you build a data center. And that's the kind of N or all those kind of different
Yeah, yeah. Also, what I found quite interesting, maybe as a sneak peek, we can quickly jump to here. Okay, no, it doesn't display. I think it has a display fault. I will show you later. Landgraph itself, they just brought out this nice overview of all different agent, multi-collaboration agent architectures. So there you have a good overview of a router, a distributor, a sequence, a loop. So they try to like just depict the whole variety of it. I'll try to find it so I can send it to you.
Sorry, very basic question. We put different agent, but not in one super agent is because like the limitation of the transformer itself. So it cannot do very complex. One agent cannot do very complex things. If we want to separate in different parts, we don't want them to contaminate each other, right?
But that's just one reason, but it's another reason. Suppose I actually talked to one student, suppose you want to write a novel, right? So you have 3 agents, actually there are 3 characters.
Mm-hmm.
And they have different personalities, they have different family background. And then you don't want to mess up everything into one thread, that's not going to work.
Yeah.
So you have 3 agents, and you don't actually have any kind of links in the beginning. You want to say, well, I'm more aggressive, you are more kind of calm or whatever, introvert. So when I start speaking something, you will just back off, something like that. So they will just play out by themselves. So those kind of situations will be really, really
Oh, it's
interesting.
interesting. I mean, I understand now. If you combine together, we only get average somewhere.
Right.
Yeah, and I mean in general, there is like right now still this big debate about, okay, how far can one reasoning model go with already accomplishing a task, maybe a reasoning model like having tool use and everything available, versus the need to build a certain agent structure around a problem, where definitely the first one, like having it all solved by a reasoning model, I would say is the better way to go, because it makes you more flexible, more dynamic. You don't have to, if you think about like coding a framework, you don't have to adjust it whenever maybe a slightly better non-reasoning model comes out. So that's definitely the way to go to, but there is still a certain limit to that, where it's still needed to put your complex task, or to solve your complex task within an agent structure. Nice. Yes?
Just curious, like, with this design patterns, like, are there any sort of failure guardrail, like in case like upstream agent or hallucinates or something happens with this output? Would it be possible for like downstream agent to pick up on like errors?
Mm-hmm. That's quite I would say a common trend, or a module that evolves in most of the agent frameworks. I would maybe not call it a design pattern, but for example, the Agent SDK, they have this core concept of a guardrail. We'll also look at that in a second, where you can check your input and check or validate the output and just keep it guardrailed in that sense. So that definitely exists, yeah.
It's kind of like each agent has its own check judge or something.
So in this case, I think in OpenAI SDK, it is per agent, definitely, but there, depending on how customizable the framework is, you can like set certain checkpoints and then decide at which point in your flow do you want to guardrail something or validate something or checkpoint something. Yeah. All right, then let's go back to the agent frameworks. So in general, for the agent frameworks, they are all frameworks that try to incorporate or implement those design patterns. As you've seen, we built them now ourselves from scratch, which is definitely feasible, but all of them, at least all of them, are incorporated in different frameworks, and those frameworks still build further on top of it and give you pre-built models. So to give you the overview, we're gonna dig deeper into 4 frameworks: the CrewAI, AutoGen, Landgraph, and the OpenAI Agent SDK. If we look at their GitHub stars, so we already saw the highest monthly downloads definitely is Landgraph. However, on the GitHub stars end, AutoGen is the winner, I guess, because it's been around for quite some time. CrewAI is next, then Landgraph, and then on the lower end, the Agent SDK, which is also only launched since mid-March. On a language side, they're all built for Python. AutoGen is the only one that also can be used with C. And I want to give you a feeling of their edge. So definitely the Agent SDK is the most lightweight framework. So definitely for beginners, or if you want to get an easy head start, the Agent SDK is your way to go. While the Landgraph and AutoGen, they're more of production-ready systems, or you can use to build production-ready systems. If we look at their differences, Landgraph, they really focus on giving you freedom to design your flow and the state, or to control the flow and the state of your application. And AutoGen is somewhat in between the Agent SDK and Landgraph, because it lets you design on a very abstract level. It has even a GUI where you can just like drag and drop different elements, but it also goes down into highly customizable agents where you can really build what you need. And a bit on a very different end is Gru AI. It tries to be the winner in terms of human-like collaboration. So in case you have a use case that's very close to human interaction, I would advise you to use Gru AI. As you see, they had like all different edges, so I just want to walk you over the core concepts of the different frameworks. With the OpenAI Agent SDK, there is 4 core concepts. One are the agents themselves, then the guardrails we just talked about, handoffs, and the tracing. So the agents themselves, they're basically just configurable LLMs that get an instruction, so a prompt that can get tools, as we also saw earlier, and then we can give them guardrails and handoffs. Guardrails, I'm going to repeat it again, are basically validators or safety checks on the input and the output, where you can just double check if something is happening that you don't want it to. And handoffs are good for if you have like a general agent and multiple expert agents, because then you can define a handoff to hand off a certain task or the control over to another agent, and then that agent can hand off back to the main agent. And what's also quite nice with the Agent SDK that it has built-in tracing, so you can view, debug, or optimize your workflows pretty easily. And in general, that allows you to really build an agent application within maybe 5 or 10 minutes, and then you have already something basic standing. The big drawbacks are that it only provides a very basic conversation memory, and it doesn't have any advanced state handling or any advanced memory. And also, it rather defaults to sequential workflows, so it doesn't allow for tasks to run simultaneously. Any comments on the Agent SDK? Yeah.
Could you share an example of a task that uses handoff?
That users handle, or that
No,
the
that
framework?
employs handoff, for example.
So what we're going to do in a second, we're going to go into one example task where we're going to compare the Agent SDK with the Landgraph. So there we can have a deeper look into that.
Awesome, thank you.
Great. All right, then let's jump on to Landgraph. The core concept of Landgraph is a graph, as it already says in the name. So it's like this directed acyclic graph, where there's different nodes in the graph and also different edges, and each agent, so to say, is represented by nodes and by edges. And the edges, they define the flow of information or the flow of tasks within that graph. And also what's quite nice to have, that the agent has a state. So you can keep track of the state, you can keep track of the memory. Also, the Landgraph, it's designed for reliability. 2 core concepts that are in there is the retry logic it inherits and the human in the loop checkpoints. So this, I think, maybe comes even close to what you're envisioning or what you have in mind. So if an action or a task fails, you can like go back and retry, and you also have like this human in the loop checkpoints where you can just validate.
So did they have that before, or after the CEO talked to me just about 3 or 4 weeks ago? Because he saw my paper and then started to be interested. I don't know whether they had that implemented already before.
We would need to look in the version history where it was implemented. We should definitely do that, but they don't have it for all too long.
Okay.
Definitely like 3 months ago, it wasn't there yet. Yeah.
Okay. Yeah, because I think he found out we have this persistent memory and auto redo compensation.
Mm-hmm.
So
Interesting, right?
yeah.
Yeah. Yeah, drawbacks of Landgraph, definitely it's way more effort to configure all like the states and the transitions if you really want to implement custom agents with it. It's just, you need to think through it by yourself and you need to make sure everything really makes logic sense. That's why it just also adds some complexity or brings some complexity with it and is not very well suited for beginners, even though it has built-in modules.
What about debugging?
Debugging in Landgraph, you can definitely do debugging. I'm sure I didn't use the, in our example that we'll go over, I didn't use the built-in debugger, but I'm sure it has a built-in debugger. I'm pretty sure. Okay, then next one is AutoGen. The core concept is the orchestrator agent, so there's like one central coordination agent, and that one coordinates specialized agents such as executors or planners, and it also assigns tasks, and most importantly, similar to like the React loop, it keeps track of the progress and track of the end goal. What is amazing in AutoGen, you can run tasks in parallel or steps simultaneously. That means it's just faster in accomplishing very long tasks or also complex long tasks. And also what you can do there is you can reassign roles or enforce policy so it has like this dynamic role assignment. The major drawback with that is just also the effort in prompting, and with like all the transitions and states you define there, is just like you need to be really thorough with not having the prompts counteract each other. Yes. And the last one before we go into the code examples is Crew AI. We already looked at a code example from that one. So just to repeat again, its basic concepts are the role-based agent that have a certain goal, a certain background, and also a certain description, so to say. And those agents are all gathered together in a crew that then is just better off in accomplishing the task or the complex task together instead of a single LLM. As we also already talked about, its major drawback is the limited flexibility that you have to make quite rigid dependency definitions. Okay, before we go into the coding example, do you have questions? Not so far. All right. Then what we are going to have a look at is the example of a real estate agent. That's just like a random example. So that real estate agent can help you to find an apartment, for example, in San Francisco or maybe also here in Palo Alto. And you can ask it questions of maybe what's a nice neighborhood to live in, or you can also pass it requirements of find me an apartment that has a maximum rent of $3,000. And this real estate agent then has different expert agents that it can call, which is like the property agent, the financing agent, and the neighborhood agent. And we're gonna look at an example where this use case is implemented in the agent SDK and in Landgraph, and we're gonna compare a bit of how the implementations differ. So let me pull it up. Just gotta see, this is Landgraph, and this one is also Landgraph. Let me just close the other ones. There we go. Okay. On the left side, we see the agent SDK implementation. And here on the right side, we see the LangChain application. I'm going to quickly spin it up just for you to see how they run. And then we're going to have a deeper look at the code. So we're going to pull up the agent SDK in the other terminal. Yeah, it launched. The other terminal, we're going to pull up the LangChain. and it launched as well. So let's reload them. Oh, already had a result. Okay, let's start with the Agent SDK one. Let's look for a place in SF. Please find me a place in SF. Which neighborhood do we want to look in? Yeah.
Tenderloin.
10. Woo, okay. And what's our budget? No, you gotta choose something realistic.
Depends on reach.
Maybe 3,000? Let's do 3,000. Let's see. Okay. So it finds us something.
Nothing.
Let's see. Oh, there we have it. Okay, so what it does, here are some rental options in the Tenderloin neighborhood of San Francisco within your budget, 3,000 per month. O'Farrell sounds like it must be in Tenderloin, I guess. Leaven Wood, we can have a look at one of them. It gives us apparently the Google Maps link, so yeah, it looks pretty much like Tenderloin. So that's not too bad. If we go back, yeah, it just gives us basically a long list of options that are available. Now we can just pass the same question to the Landgraph implementation and see what it does. Takes a bit longer, seems like. Oh yeah, okay, here we have the answer. As we see, it's way more text than on the left side, but it also says blah, 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 blah. I found some resources that list apartments for rent in San Francisco, including the Tenderloin area for under 3,000. So if we look at the first one, what is quite nice, what we see here, okay, the area is a bit large. I guess it's not really Tenderloin, but it put the filter on a budget below 3,000, which I think it did quite nice. And also it linked not only the maps, it linked the apartments.com, which I think is a bit of a better output in that case. Okay, if we look into just the stream, so this one, let's see, is the Landgraph implementation. And if we look at the log, we see, okay, it's initialized a web search tool, it initialized all agents, and the Cradio interface as well. And then it started processing the query, and it delegates right away to the property search agent. So remember, there was the one central agent, the real estate agent, and then there was 3 expert agents. So this one is one of the expert agents, which is the property search agent. And then it seems like it's going back and forth. So it's going back to the coordinator, then again property agent, then to the coordinator, then property agent, and it keeps on doing this. And in the end, it says, okay, completed with final answer, and it returned us the answer. Now we can also have a look at the Agent SDK. Here it starts out with initializing the interface, and then it also initializes its own web search tool, and then it creates all the different agents, including the real estate agent, and then it processes the query, and it checks down here for the handoff. So this is like this typical concept of the Agent SDK, where this handoff is really central, and then it hands off also to the property search agent. In this case, though, only once it seems, and then it returns back all the listings and the final result. So there, I guess the flow of the agents are just a bit different in both frameworks. Now, in terms of code, there is 3 things I want to discuss with you together. The first thing is the tool landscape, so to say. In this case, in this use case, we need access to the web, and we discussed earlier, the Agent SDK has this really nice built-in web search tool. So this is this class here. We can just import it directly from the agents package and then instantiate it down here. And we then can pass it later in our agent. So the property search agent down here is passed with all its variables, and there we just pass the tool. Now, this, we also have the opportunity in Landgraph to do web search, but a bit more complicated with that third-party tool. I use this Tavily client. So what I have to do here is import it. Then I have to instantiate the client, the Tavily client. And here we need to define that web search as a separate function with the tool decorator so that the agent is aware of this tool being available. So as we see, it mostly leads to a similar result. However, I think this one is definitely quicker to do. Now, the next thing is, how are the agents actually created in the different frameworks? So if we look at the OpenAI SDK, we can go back to just any other agent. For example, the create mortgage agent. And we see down here, okay, an agent, there's this agent class, and we can pass it a name, instruction, and tools. And this is basically the basic setup for an agent. In this case, the instruction are just the prompt. So this one we can do as holistic as we want to. And the tools, all possible tools that it's supposed to use. So this is really easy going. Now, if we have a look at Landgraph, then this is actually quite similar. Just gotta see where we have it. So let's, for example, take the property agent again. We can use this method create React agent, and this leads us with pretty much the same thing, only that this create React agent is just a pre-built method, and it's not the most standard one, but it's one of the pre-built methods that is available within Landgraph. And this create React agent is exactly the React loop we looked at earlier in the design patterns. And there we also just define which LLM we want to use. We pass it its tools, and we also pass it a prompt. In this case, I just wrapped a simple make system prompt function around it. This one we can find here, and it just adds like an additional prefix to the prompt. But other than that, it does nothing special. So I would say, in terms of defining an agent, it's pretty similar because we have simple pre-built agent classes for both frameworks. However, I have to admit that it took me quite a bit to figure out, okay, which of the Landgraph templates should I use? Does it make more sense to maybe build a custom agent, or should I really use it? So this is where you just need to spend more time or more thoughts on. And yeah, the last thing we want to have a look at is the handoffs itself. So OpenAI SDK is quite known for its handoffs, and the way we do it is actually pretty simple. So we have the central real estate agent, and then we have the expert agents. And in the central real estate agent, which is this one here, we just define the handoffs. So there's one input variable called handoffs, and there we can just list all the other agents that it's supposed to hand off to. Now with the Landgraph, it's a bit more complicated. Here, if we have a closer look at, we need to define extra functions for that, for the handoff, and the output of that function needs to be a command. So basically, if that function is called, the command is to hand off to another agent. And in this case, we want to define the handoff command to hand off to the property search agent. And here we just have a small logic of, okay, maybe the real estate agent is already at the end and it just returns the final answer, or it hands off to the property search agent and then actually returns this command for the handoff. And in this way, we need to like define each handoff so we don't have like a simple input variable, which is more effort, but also gives you more flexibility in, for example, defining handoffs and how the handoff is supposed to look like exactly. So you can just put more thought into that if-else logic. Yes. And those, I would say, are the main differences between the two frameworks if we really only want to implement that simple use case as we did it right here. So with both frameworks, it's possible. You can implement that simple use case. Now with the OpenAI SDK, it probably took me like 10 minutes, so it was really quick. Now with the LangGraph, I probably took around 30 minutes or something, so you really have to take your time to go through the docs and kind of like figure out, even though it's really only a simple use case. And last to mention though, with the LangGraph library, there you definitely have like more functionality that you then now can just use to extend the use case. For example, instead of running synchronously here, you could just like use an async function to have all the expert agents run in parallel and be faster in accomplishing the task. Yep. So, any questions on comparing those two frameworks?
One thing we tried to accomplish was, so we had the algorithm in the middle. Once you give us the specification, let's say I want to do ride sharing. I have lots of vehicle driver like Ubers, and I have different customer call in. And the optimization is minimizing the distance driven by those drivers, right? Minimizing the cost. So in that situation, we can automatically generate a planning workflow, different locations and different vehicle, their locations and passengers' locations, right? Once that, after that was generated, then every single node comes here to be operation code, right? And then we have to assign agents to every single dependency or state.
Yeah.
And that potentially can be just written by LM themselves. We don't even need to write code. Right? That would be ideal.
Yeah, I see your point. I see your point. That would be quite interesting. But also, I think with that example you just mentioned with optimizing like for the shortest distance, they're like the first step towards it would be like definitely giving LLMs tool use to like run simple optimization problems and to even figure out the first state of the whole graph, so to say, and then you can like process it with a certain step size, I guess, in terms of time, and re-optimize. And then, yeah, the next step would be what you just described.
That would be interesting.
That would be very
even
interesting.
less code to be written.
For a lot of physical problems as well. Yeah. Yeah.
Which one would you choose for production?
The-
In terms of scalability and
Yeah. So for production, definitely LangGraph. I would choose over the Agent SDK because Agent SDK is really nice for like little examples or just to test something. However, it doesn't give you enough freedom to build production-ready systems, and it also doesn't come with a memory, which limits it a bit. Yeah.
do you have any examples of where you notice these limitations, except of memory, other than the memory issues?
Yeah, so one example, for example, would be running tasks in parallel. So you just need to do your sequence and you need to wait for it. I'm sure they're gonna soon bring something that somehow parallelizes the whole thing, and I'm sure they're also gonna bring a memory module at some point, but they're just not there yet. And also, just in customizing things. So looking at handoffs function here, this is like also a handoff function here. You could like put in further conditions that you want the handoff to happen. So you maybe want to restrict it to really narrow conditions. I generally want to hand off to this expert, but only if. And this is something you can definitely do here, but I have not even tried to do with the Agent SDK. I just think it's not possible. Yeah.
That's a potential to start a new company, right? You can implement another entity called either alert or called trigger. Trigger on certain conditions. When that condition is met, you trigger an agent to execute.
Yeah.
Rather than just keep on kind of online run robin and look at all the conditions. But this is like, well, I'm not doing anything until the condition is satisfied, and agent will be triggered.
And then spin it up and have it run. Yeah. So more of like a hybrid deterministic stochastic system. Yeah. Yeah.
What tools have you found most useful to generate code like this?
Good question. So I'm a passionate cursor user. Yeah, I mostly use cursor. I've tried Devin. They now have a cheaper subscription as well, so you can just go ahead and try it. I never tried Windsurf, and I think cursor with the last update got worse. So since maybe like 1 week, I don't know, it just doesn't perform as good anymore in my opinion. But yeah, I use cursor, and then sometimes I just, if I want to have a longer intense chat, I copy and paste it to Claude or to the 201 to figure out some complex things. Yeah, other than that, I'm good. I would be interested, what tools do you use? Same, yeah. Have you tried Windsurf? Okay, yeah. Anyone using the Copilot? Yeah, back there? Nice. I think they also had some updates recently, so it got better. Good. Yeah. Further questions? Yeah.
How do you see both platforms for methods evolving becoming in 1-2 years?
How I see the agent frameworks evolving, or?
No, OpenAI has SDKs and then languages.
Interesting question. I am maybe just gonna switch over to a question in regards of that, and that's also a question I want to turn back to you just to wrap up the class. So the question is, where do we see them evolving? Do they really have their need, or will people just code up everything from scratch? Because as you guys seen, we just did it in half an hour. We implemented 4 design patterns. It wasn't too hard. It's basic code. And I mean, what the agent frameworks do is also just implementing these design patterns, and now are slightly on the way to like come up with like better mechanisms or better concepts and really think it through. So doing the hard part, because doing the hard part is not writing the code for it, but thinking through the architectures, thinking through the elements that you need in those architectures to have them fully functional and to have them reason in a better way. And I think right now we're still at a stage, to be honest, where we can say, let's just code. Maybe we don't even need those agent frameworks at some point anymore. But I also see a world where they really become better in defining the elements we need for full functionality, defining the concepts around it, the mechanisms around it, and also becoming better in reliability, in validation, in rollback, in retry logic. And if they manage to become better in all of that, then I think they will be better and also more dynamically usable. And then I see them somewhere. Now the question is, who is the winner, right? I think there will be no winner right now, or it's hard to tell right now. Yeah.
For specific companies, what winner for interest of which one you want to use then?
Which agent framework you want to use. Definitely there's going to be probably a winner in terms of AGI or just AI companies, but I think in terms of agent frameworks, there will be multiples around for quite some time. Yeah.
I think the OpenAI agent framework was released like 1 or 2 months earlier. Like, it's very recent. How did you stay on top of all of these? And like really testing and tracking it?
So really testing or getting like hearing about it?
I mean, I heard your lecture last quarter in the class, and it has really changed.
Yeah.
You know, like 2 months.
A lot of stuff happened, right?
Yeah. So how do you stay on top of all of these?
Yeah, I mean, I'm just naturally curious whenever something new comes out. It's fast to try them out, I would say, and that's also hopefully what they're kind of there for. So I just follow the different people on Twitter. For example, also the LangChain or LangCraft CEO, or there is also another company called AgentOps AI. Somebody heard of that one? Not AgentOps.ai. They also have an agent framework, one of the many. And they post a lot about new evolvements, and then just if it comes out, just code something up with cursor, and then you kind of like understand what are the drawbacks, what can I use it for, what can I expect from it, and you get a feeling pretty fastly, I would say. Yeah. So question though, back to you. What are your opinions? Do we really need agent frameworks? I don't know, who of you have recently coded on an agent project? Show of hands. 4? All the others didn't? or don't? Okay, then to the four of you, do you think we need agent frameworks?
Yeah, it's very useful, specific for helping with specific workflows. So in very applied problems, yes.
Okay.
It was very convenient.
And would you say because it's easier to get started, or do you also say you'll grow with the framework?
More both, actually.
Okay. Yeah. Interesting. Yeah.
I still think today, given the limitation of the one agent can do, we cannot have a mother agent to generate like small their subordinate with automatically. So this framework help us a lot with in playing today's like limitation. Maybe Yanagun, I don't agree with him, but maybe it's sound cool to say like we are building AGI that's more smarter and we don't need any like framework and at all. They can do whatever they want. They can do. So today I think we still need this. It's very helpful to sort our methods to help make things done. But I don't know whether in the future we're going to do. Yeah.
Also interesting thought.
I want to say one on that in
Yeah.
that context. Yes, AGI will solve a lot in that sense. Of course.
Guess so, yeah.
But before we get there, in terms of all system designs, if you want to automate any system, no matter what system you're in, there's a lot of more routine problems or tasks that is supposed to be done. And using a agent framework, then you can use that almost like oil in a mechanism, that makes the machine actually run. Like it laps over all the.
So yeah, you need some
problematic
layers.
edges.
Yeah.
So it becomes so it smooths out and opens up a lot of opportunities to be able to work with quite complicated and inconvenient systems and still make it work.
Yeah, I agree. So it will be definitely more adjusting to its environment at some point. Yeah. Great. Then, thanks so much everyone for sticking with me. Also, if you have any further questions, reach out to me on email or add me on Twitter. And also, I'm here for a few more minutes, so if you have questions, just come approach me.
Thank you.
And thanks so much again for inviting me.
For your lecture will be uploaded somewhere. We can kind of review it or send me the link.
Yes, I'll send you the link, and also we recorded the lecture, so I'll send you the link and you can distribute it.
Thank you so much.
Great. All right. Thanks so much. Have a good one.